Hello, Sahel community. Today is the 11th October 2025. And what time we have there? Let's go right here in Google and say actual time in Germany. So, so you can see here actually the time that you have actually. So it is already a couple of days that we implement the inter-VLAN routing. And our last setup was this one, and we are going to continue exactly where we stopped last time. So meaning in this setup, PC0 and PC1 were able to reach each other, and PC0 were also able to reach PC3 and PC4 in a different VLAN. Now, the point is we mentioned some drawbacks. What was the drawback? So look at this presentation right here. I draw it here for you to have exactly the step we're going through. So this is the actual setup. It's red because this is not a setup you will see out there in the industry, and it is quick and dirty. I personally call this quick and dirty setup. It do its job, but it has a huge limitation. So uh, the more VLAN you create, the more cable you will have here between the router and the switch. So the router has not infinite interface available, neither the switch. So the upgrade will be for you as a network designer, as a network technician, to go to the route on a stick. So what does this mean? What's the difference here? We still have pretty much the same setup, but the difference is you have between the router and the switch only one cable, and that connection is an ISL or a .1Q, 802.1Q. So we should configure that as strong on the switch side and on the router side. So, and the drawback that we have here is the latency, the delay, and the bottleneck, because the communication from the PC go up to this. If PC 0 want to communicate with PC 3, let's say PC on the green area want to communicate with PC on the blue area, the communication will mainly go up there to the router and come back over the same single physical interface. You agree with me? The more data will flow, the more you will get into the bottleneck. So if you have only, let's say, 1 gigabit link here, and you are sending more than 1 gig communication, so you are even about 1 gig data flowing from the green to the blue, you agree with me that you quickly get into a bottleneck. So how do we configure that? It is pretty simple. We go here on the router. What we'll do is to, I want to disable the one link here. Let's delete the router directly there, and we set up the router again. We put there the one router, and we connect with one single cable. Let's say port 24 and say gigabit 00. So let's go directly on the router. What we'll do on the router, look right there. We have two VLANs. I will say last time it was VLAN 30 and VLAN 50. As you see here on the diagram, VLAN 50 and VLAN. How can I put that on the side that you see exactly what I'm configuring? At the same time, let me make a screenshot like this and put it right there that you can see exactly what I'm configuring, I hope. So we go to the CLI of the router. We say no. Show CDP CDP neighbor to see where the router is connected to. Show IP interface brief. The interface you see here, we cannot see the neighbor because the interface is down. Contain int gigabit 0, 0, 0. We say no shot. We see do show CDP neighbor. We can see that we are seeing the neighbor on gigabit 0, 0. We go there, we say interface gigabit 0, 0, 0 dot 50 was the VLAN with 192. We say 50. Look, when we did make show IP interface brief, we just see the physical. This is the physical. What we are creating here is the logical interface with this number here. With this number, our VLAN ID. Okay, so we will get to that later. So the VLAN ID. So I prefer giving the .50, and the next command will be that we are in the interface. We say encapsulation .1q, and we give the same number 50. Do show IP interface brief. Look at the difference right here. At the beginning, up here, we had only the single physical interface. Now, what have we created? We created a logical interface, meaning on this link here, we create a, is it the green? Can we take the green one? Yes, we create a sub interface right there, right here, under this physical interface. Okay, this is that sub interface. Now we're going to IP address 192.168.1.254, 255.255.255.0. You already know how to assign IP address. We did last time. No IP proxy app, and it should be already up. Do show IP interface brief. You see, it is there. It is there. We do the same thing with the with VLAN 30. With VLAN 30, we put here the 30 encapsulation.1q 30, and IP address was a 10.10.1.254 255.0.0.0. No IP proxy. Okay, do right. I save the configuration. Okay, look, do show IP interface brief. You see both IP address show run. Do show run. Look at the interface configuration. Pretty simple. How we apply from the router? We can make some ping from the router. Can we ping PC with the 192.168.1.1, 192.168.1.1? Of course not. Why? Look right here. We cannot ping because the switch side is configured. The switch side is not configured now. Okay? We haven't configured the trunk on the switch side. So we go to the switch side. So show CDP neighbor. Where do we see the router? The router is seen over fast Ethernet 024. Let's say the show run. How is the fast Ethernet 024 configured? It is configured as we left it last time, as a user port. I will delete the configuration on that. I say default interface if fast Ethernet 024. Okay, do show run. Look how the interface 24 is actually. This is the interface 24. I will go to interface FR024. I will say switch port, come on. Yes, it's taking. Was my PC was a little bit slow. Switch port mode trunk. Okay. Switch port encapsulation. Switch port trunk encapsulation. I'm looking for the .1Q. I don't know if there's limitation on this configuration. Switch port trunk encapsulation. You're going for native. Maybe it doesn't have this, the second command right here. Okay, do show run. So which configuration? What was the configuration here? It was only switch port mode trunk. Depending on the platform, there are some of the configuration that might not be taken from the equipment, from the switch or from the router. So when we will be on my home network, you will see that I will show that configuration right away. Okay, we are here on the router again. Let's ping that once again and see if the ping will be successful or not. Look right here. The ping is there. The ping is successful. Why? Because we configure on the switch side the port as strong, and on the router side it is also strong. We did configure the sub interfaces. Okay. Now the router can ping this PC. Can it ping this PC in the 10? Look at this. 10.10.1.1. Yes, you will ping it. Look at that. Okay. So, question: can PC 0 ping PC 3? I say he can ping it. Bam. It isn't that beautiful and simple. So what are you still waiting to start with the IT networking? So those are example of the industry implementation. Pretty simple that you can set up in your packet tracer and learn with that and move forward. So you see the limitation as I presented in here. The limitation here is that if this router has an issue, you will the VLAN, the inter-VLAN communication will not work anymore. So you cannot move from green to blue anymore if it has a problem. If you are sending too much data, you will have a bottleneck here. So how to solve that issue is solved in the option 2. You see that in the option 3. You see that option 2 here is yellow, meaning you can implement it if you are in an environment where you don't have a layer 3 switch. But if you have a layer 3 switch, then another better design is to be considered. And let's look at that in the second video. Bye-bye.